So our recap for Chapter 3. So to this point, we've spent a bit of time talking about graphing. And we talked about the techniques we'd use for graphing in vertex form, intercept form, and standard form. And then the last piece, we've spent a lot of time talking about how we convert from vertex form to standard form to intercept form. What I want to transition to next is solving. Solving a quadratic is a little bit different than solving a linear equation. One reason it's different is because we have several different techniques that we can use to solve a quadratic. Some of them work some of the time, but are easy. Some of them work all the time and are a bit more complicated. Some of them work all the time and are still pretty easy. It's just a matter of finding the technique that's acceptable or reasonable to use in a given situation that are effective for you. So we're going to talk about several of these different solving techniques over the next couple of days. The first solving technique that we're going to talk about, though, is using factoring. Since we've just been talking about factoring, not only is that a way for me to change my function from standard form to intercept form, it's also going to be a really effective solving method for me. So the key idea is going to be this. So the key idea is when we multiply two things together, and get 0, we know that one or both of those two things have to be 0. This is the only number that this is true for. We give this observation a special name. We call this the zero product property. I often abbreviate that as ZPP. So just to kind of make an example, if I say I have x times y and I give me 0, that tells me that x would have to be 0 or that y would have to be 0, right? This doesn't work for any other number. Suppose that if I have x times y equals 1. Well, x could be 1, y could be 1, but x could be 2 and y could be a half. Or x could be 3 and y could be a third. And this would go on over and over and over again. That doesn't really work for me. Everybody okay with that idea? So the procedure then for solving by factoring the first step would be to make the equation equal 0. So if you have to add or subtract things from both sides to make it equal to 0, that's the first step. We can't do anything if our equation doesn't equal 0. Have to have that happen before we do anything else. Grace? Once our equation is equal to 0, we're going to factor. And then our last step is to set each factor equal to 0 and solve. That's our procedure for solving by factoring. Let's do an example now to practice this procedure here. It's a pretty easy procedure. So let's say we have x squared plus 6x plus 9 equals 1. First thing I should do is make this equation equal to 0. So I'll subtract 1 from both sides. Okay. The next step would be to, good, next step I want to do is to factor. How does this one factor? We can use the shortcut. Specifically, what would be the factors? So I need the two things that multiply to give me 8 and add to give me 6. Those two numbers would be 2 and 4. So I can write this as x plus 2 times x plus 4. On these shortcut ones, I'm probably going to stop writing down the little sub-questions and just write down straight to the factored form. Is everybody okay with that? So we factored. My last step now is to take each of these two factors and set them equal to 0 and solve them. So my answers are -2 and -4. This step, though, where I set each piece equal to 0, only works because I have, in the previous step, two things multiplied together that equal 0. So I'm using the zero product property to go from that factored form equal to 0 to the each factor equal to 0. So that's where the zero product property is occurring. Everybody okay with that idea? And this is it. That's the procedure. It all basically looks the same. If you can factor, you can certainly solve by factoring. What's the catch here? Can I factor everything? So the catch with solving by factoring is that you can't do it all the time, right? There's some things that I can't solve by factoring. Although it's a pretty easy procedure, right? It's pretty fast. If you can factor effectively, this is a pretty effective solving method. The catch is that it doesn't work every single time. There are some quadratics that we can't factor. And I just want to be like really mathematically correct here. When I say factorable here, we really mean over the integers where the coefficients of our factors are integers. Actually, every quadratic is factorable, but we don't have the tools yet to kind of do that, and that's a bit beyond the scope of this course. But just to be clear here, we're going to say factorable or not factorable. We're really talking about over the integers, where the coefficients are whole numbers. That doesn't need to be the case. These things that we can't factor with whole numbers, we could factor with, some other kind of number, perhaps a fraction or a decimal or something different. Okay with that idea? That's as much as I want to do today. This is it. I want to introduce this idea of solving by factoring, because I still would like us to practice more with the factoring. This is a great avenue to doing more factoring practice. Plus, I think we're almost out of time here. So that's good timing on my part. If you guys check